what is machine learning? From this question itself, you guys could understand that the machine is gonna learn something new. Okay, before we get into today's session, let me give you a quick intro about the traditional computer program. And I think this explanation would help you to understand machine learning concept even more better. This slide describes the traditional computer program. Let us assume the central box is our computer system with the pre-installed computer program Python. And this computer program will perform an action, the sum of input variable A and B. I have defined the input variable A and B in the left side of our computer. Also, I have defined the output variable in the right side of our computer. Okay. Now the setup is ready. Also, our system is ready to execute our Python program. Now we're gonna run our program with the input variable A and B as 10 and 10, and the output variable C will become 20. Again, we are going to run our program with the input variable 5 and 5, and the output variable C will become 10. You guys all know, right, how our system will derive the output variable C with the predefined action in the Python program. Okay, this is completely acceptable and this is fine. Okay, now if we ask our computer system to perform another action like multiplication or division, will it work and will it be executable by our system? No, right? Because computer is capable to do the action only defined in our program. Yeah, that's it. This is called traditional computer program. Machine learning model. You may think this machine learning model looks similar to our traditional computer programming model. Yes, you are correct. This model similar to our traditional computer programming model. The machine model is replacing the computer program in our system, and the feature variable is replacing the input variable, and the target variable is replacing the output variable. Okay, fine. Don't get confused with this jargon in the machine learning model, feature variable and target variable. We will see below in detail. Why machine learning? Below is your task. Gender identification. Okay. If I ask you to predict the gender for the given name, will you able to predict the gender from the given name? Yes. We as a human can able to predict the gender from the given name. Sachin, Nadal, Modi, and Ronaldo are the male. Mother Teresa, Venus Williams, Serena Williams are the female. Okay, fine. If I ask the same question to our machine, will our system predict the gender for the given name? No, absolutely no. Why? Because the system do not know name and gender. Do not know what is name and what is gender. That's why we are entering into the machine learning. By using machine learning, we are going to teach our machine or train them with the future variable to predict the target variable. The feature variable is nothing but the variable which is used to train the machine to predict the target variable, and the target variable is derived from the future variable. Okay, fine. Let's move on to the next slide. Now we are going to see two examples for the actual machine learning model pipeline: gender identification and dog breed identification. From gender identification, we are going to see how our machine is going to learn from the raw data for predicting the target variable. And from the dog breed identification, we are going to see how machine is going to learn from the image, the soft copy of dog, for predicting the dog breed. Okay, let's move to the example one. Gender identification. Step 1. We have to be ready with our raw data. Yes, we are ready. Now, okay, fine. Okay. In our scenario, we are going to see the dress code. Male and female are shirt and sari. Just keep it in mind. Don't get confused with our raw data. This is not a raw data. The highlighted one in the screen are raw data. Moving to the step 2, data analysis. In our problem, we're going to see the gender identification. So the gender is our target variable and all other variable in the raw data are feature variable. Okay, fine. Moving to the step 3, pre-processing. Here we have to identify the irrelevant data to the target variable. Okay, in our example, we do have two irrelevant data for the target variable. Serena Williams has blank value in the age column and Ronaldo has dress code pant. As I mentioned in the step 1, in our scenario, we are going to see the dress code only shirt and sari. So this is the outlier. Either we have to remove this to entire row from our data set or we have to add or update some value in it. Okay, I have added shirt, correct value, correct dress code for Ronaldo and the age, the mean of available age column to the Serena Williams. Okay, the pre-processing is done. Moving to the step 4. Here we have to separate two section from the raw data training and test section. Okay, let me give you another small example where you could understand the step 4 even better. Okay, I'm opening sheet 2. Here we have two section, training session and exam section. I'm gonna conduct exam now. Okay, before I'm gonna conduct the exam, I'm gonna give you some set of question where you're gonna train on it. Okay, I have given the question 1 to 6 and also I have given the answer for that. Okay, once you get trained in the training section, come to exam section. Okay, here I have asked the same set of questions which you have trained in the training section. Okay, your answer is also a correct. Okay, now the score of your performance is 100. This is how we evaluate your performance. No, right? Okay, I will give you another example here. Okay, I have removed the last two questions from the training session. Okay, now come to your exam section. If I ask the question, same question which was in the training session 1, 2, 3, and 4. Also, I have added two more new questions. Okay, Q5, Q6. No, okay, so if I ask you to answer all of these questions, you will answer the correct answer for only question 1 to question 4. And question 5 and question 6, you're gonna answer based on the pattern which you got from the training session. Okay, this is the correct way to evaluate your performance here. In the same manner, I'm just going back to the slide 4. This is how we have to evaluate our trained model. We have two separate data set, one for training the model and another one for evaluate the trained model. Okay, okay, fine. Step 4. Moving to step 5. Here we have to choose the right mission model and then once you choose the right mission model, we have to train the mission model with the trained data set. Here I'm not going to teach you completely, but I'm going to give you some insight about how to choose the right mission model. Okay, I have added the link below which will redirect to our choosing the right estimator. This is the Python package skykitlan. Okay, okay, here you can see the rectangular, sorry, green color rectangular box. This all are a estimator or model. Okay, model. If you click each rectangular box, it will redirect to the appropriate model. Okay. Yes. Coming back to the home page. Here we are gonna identify the category where our gender identification falls under. Okay, so in our example I'm just going to start from here. We do have more number, just assumes we have one number of data set, we do have more number of data set, and it comes to the next circle predicting the category. This is the important one. So whether we can able to predict our raw data with respect to the target variable. Yes, correct. We are gonna, in our example we are gonna see the prediction of gender. This fall under the categorical male and female. Yes, correct. Now coming to the next circle, label data. We do have a labeled data, right? So see, this is label. We do have label name, age, dress code, and gender. Okay, we do have it. Then see where it goes. Classification. Yes, correct. Our example is fall under the classification model. Okay, this is how we have to identify the right estimator. So this each green rectangular model are applicable to our scenario. Okay, let's go back to our session. Okay, once you choose the right model, you have to train the model. Okay, step 5 is finished. Once you train your model, come to the step 6. Here it's a prediction. Here you have to predict the target variable from the feature variable for the test data with the trained model which we trained in the step 4. Okay, the same model here we have to use to predict the target variable. In our scenario, the target variable is predicted correctly, then the accuracy is 100. 100. Okay, this is how the actual machine learning model pipelines is going to work in the real scenario. Okay, let's move to the next example, dog breed identification. Let's see dog breed identification. Here we are not going to follow each and every step which we followed for the gender identification from the machine learning model pipeline, because here we are going to use teachable machine is a web-based tool that makes creating the machine learning model fast, easy, and accessible to everyone. The teachable machine learn, teachable machines. You can Google the word teachable machine. You can get this website. Okay, let me also quickly walk through this web page. Here they have added the link of initial version of teachable mission web page from 2017. How do I use it? They have provided the step to train the mission from teachable mission. What can I use to teach it? Here below they have provided the 3 problem: image, sound, poses. Out of these 3 problem, we're gonna use image for predicting the dog breed in teachable mission web page. Okay, they also provided the tutorial of each problem: image, sound, pose. Okay, fine. Let's see dog breed identification. I have downloaded 2 dog breed image from Google: Bulldog and German Shepherd. I have downloaded 4 different types of image for Bulldog and 3 different types of image for German Shepherd. So out of 4 image, I'm going to use 3 images for training and one, the last one, Bulldog 4 image. I'm going to evaluate the trained model. Also, I have going to use 3 image of German Shepherd for training. So totally, I'm going to use 6 image, 6 image for training and 1 image for evaluating the trained model. Okay, fine. Get started. And we are going to work on image classification problem, which is dog breed identification. So just click the image project. And here we have two classes. Each class denotes the dog breed classification. So first we have to change the class 1 to dog breed name. I'm going to change here bulldog and class 2 to German Shepherd. And now I have uploaded the image for bulldog. Also, I'm going to upload German Shepherd training set. Now we have uploaded the training data set. Now the next step is we are going to train the model by clicking the train the model option. Okay, it may take 1 to 3 seconds. Once it got trained, we will get here the target variable. Now we have to upload the image for evaluating the trained model. So I am going to upload the image which was not in the training data set. Bulldog 4 image. Once you upload this image, our model will predict the image which was uploaded is bulldog. So our prediction is 100% accuracy. So this is the sample machine learning model for unstructured data. So far we have seen two different type of machine learning model. Did you find is there any difference between two different type of machine learning model? Gender identification and dog breed identification? Yes, you are correct. We do have some difference between these two machine learning model. In gender identification, we have used structured data to train the model. And in dog breed identification, we have used unstructured data to train the model. What is structured and unstructured data? Structured data is nothing but each class have some unique pattern. Okay, the class one here, the Sachin, the row of 79 is the class one, and here class 1, and the row 18, 80 is class 2, and likewise it goes on. Okay, each class have some pattern like name, age, and dress code, and the gender. This is called structured data and unstructured data. Here we have four different types of image for the same breed, bulldog. Okay, there is no pattern between each image of bulldog. So this is called unstructured data. I hope you guys enjoyed this session. Thank you.